Hello everyone, welcome to my channel Chemophily. Today we are going to discuss aldol condensation and I am going to solve various examples of your previous year question paper. Taking this as the first example, we have disconnected here to get two types of synthons and synthetic equivalent. From here, using aldol condensation, we have synthesized the target molecule. Please note it down. Taking another example, here you have to do FGI before moving on to disconnection so that we can get our required synthetic equivalent. Then we will synthesize the target molecule using aldol condensation. We will dehydration is used to get the target molecule. Please note this was one of your question in previous year question paper asked to synthesize this target molecule using Wittig reaction. So you know Wittig reaction is a reaction in which carbonyl compound is treated with phosphorus yield to get required alkene molecule. Okay, this is the synthesis of the previous example. Using the two synthetic equivalent, we have synthesized our required alkene using Wittig reaction. Now we will proceed to disconnection using where there is carboxylic acid. See, we have taken this as the example. First we will do here FGI. Hydrolysis we have given here because of the back reaction. You will note it when we will do the synthesis of this. See, here we have done disconnection to get this two type of synthons. From here we get two synthetic equivalent. This is known as diethyl malonate. Please, this is very important. Note this. After this, we have synthesized our required compound. Here Br will leave and this minus will attack here, so that we get our target molecule like this. We have hydrolyzed this, and after dehydration, we carbon dioxide after heating. When you heat it, your carbon dioxide will be removed and you will get the target molecule. I am moving a bit faster. Please note everything. Now we will solve few questions of the previous year question paper. This was one of the question. We are asked to synthesize this. This is 1,2 difunctionalized compound. Okay, 1,2 difunctionalized mean in this carbon there are two different type of functional group. We will disconnect here so that we get this two type of synthetic equivalent, these two synthetic equivalent. From here we will proceed to the synthesis as follows. I have not written which year question is which one. Okay, please see it. This is another example. Here we have done another something. See, functional group addition. We have added a functional group so that our disconnection becomes easier. We will disconnect the compound here and we get this two. From here we get two synthetic equivalent. Taking the synthetic equivalents, we will move forward to synthesize the target molecule as follows. This will attack here so that we get, after hydrolyzing this, we get this. Hitting this in presence of iodine, we get our target molecule. This is our third question. Using Wittig reaction, we can solve this. We will disconnect here. We get two synthon and the synthetic equivalent. One will be phosphorus yield. Now we will proceed to Wittig synthesis. Doing Wittig, we get our target molecule. I am not showing the details of the Wittig reaction. You can also do it by seeing your books. This was another question where it was asked only to show the synthetic equivalent. Here first we will do FGI so that our synthesis becomes easier. We got this two type of synthetic equivalent. This was only asked in the question. This was another question. We will directly move to disconnect it. We will disconnect in these 2 points so that we get these two synthons. Now we will move forward to synthesize it. This two was our synthetic equivalent. Please note it. Now bringing into the another synthetic equivalent. Now this reaction will undergo SN2 mechanism. As this question carried 2 marks, we have to show all the detailed steps. We got our target molecule. Please note this. This was a question asked to solve by reverse Wittig. First we will do FZI here. After doing FZI, we will disconnect here. These are the synthons and synthetic equivalent. Please note the synthesis. This was one another question for 2 marks. We will first do FZI here. FZI by hydration. Then we will disconnect it here. One we have made Grignard reagent and another carbon dioxide. This is the synthesis. Please note it. In this example, you was asked to synthesize this so that ethyl acetoacetate acts as a reagent in this compound. So let's see how we will do this. First, we will disconnect. We will disconnect it here. Ethyl acetoacetate we got here. We will proceed to synthesize it, giving it a base. Then adding the another synthetic equivalent. This is the synthesis. Please note it down. This was another example. We will move forward using Grignard reagent. We will disconnect here. These are the synthons and synthetic equivalent. Now moving forward to the synthesize it. This is the synthesis. This is another question. This was for 3 marks. First we will do FZI here. Doing FZI, we have made NH2SN3. Azide we have made this. Then we will disconnect it here. So that we note this, I have disconnected in this bond. This bond is already intact. So here one positive charge will come and here one negative charge, and this will become epoxide. See, this is the synthesis. Under reflux condition we get this, and by reduction with lithium aluminum hydride we get our target molecule. This was another question. This was also for 3 marks. We will disconnect here the 2 phenyl group. I am directly writing the synthetic equivalent phenyl magnesium bromide we get from the 2 phenyl group. First we will take 1 molecule of phenyl magnesium bromide and we will proceed to the disconnection like this. We will proceed to the synthesis. Like this we have synthesized it further. Now here the other molecule of phenyl magnesium bromide will come. This is the complete synthesis. This was another question which also carried 2 marks. We will do double FZI here to get this, and here we will disconnect so that we get this 2 synthetic equivalent. From here we have proceed forward to synthesize it. Please take a screenshot of this or note it down. Here you see, this is very important, cerium oxide. We have used this to make here another ketone. So here I have completed the chapter with as much possible questions as much I can, and thank you for watching. Please subscribe to the channel and like and share it. Thank you.